The art of trigonometry is a very beautiful one. I'd like us to try some trig on orthogonal components. Many of you are familiar with SOHCAHTOA, so let's review. The SOH in SOHCAHTOA is for sine, by definition is opposite over hypotenuse. The CAHTOA is for cosine, by definition is adjacent over hypotenuse. And tangent, of course, by definition is opposite over adjacent. I've got 6 problems. Let's look at the first one. We've got a 50-pound vector and it makes an angle of 15 degrees with respect to the y-axis, and we are interested in finding its y-component. So all we have to do is just project it onto the y-axis, draw the component, and think of this in terms of SOHCAHTOA. 50 is the hypotenuse. The component that we are interested in is adjacent to the 15-degree angle. So we've got hypotenuse, which is the 50-pound vector. The component that we're interested in is adjacent to the 15-degree angle. So therefore we must use cosine. So the y component of the 50-pound vector is just 50 cosine 15. It's as simple as that. How about the second problem? We have a vector and we'd like to find its x component, so project it onto the x-axis, draw the component, and the hypotenuse is 20. The x component, which we're interested in, is adjacent to the 55-degree angle. So we've got hypotenuse and we've got adjacent. We again must use cosine. So the x component of the second vector is just 20 cosine 55. The third problem, 60 meters is the resultant, and we'd like to project it onto the x-axis. Draw the component, and with respect to the 32-degree angle, well, this component is equivalent to this component, which is opposite of the 32. So we've got 60 is a hypotenuse, and the component that we're interested in with respect to the 32-degree angle, that's opposite. So therefore we must use sine. So the x component is 60 sine 32, and since it is to the left, I must put a negative sign in front of that term. How about this? 400 inches, and we'd like to find the y component. So project it onto the y, draw the component. 400 is the hypotenuse. The y component that we're interested in is equivalent to this component, which is opposite of 27. So we've got hypotenuse, which is 400. The y component that we're interested in is opposite of the angle, therefore we must use sine. So the y component is 400 sine 27. Okay, how about the fifth one? We've got a resultant, which is 500, and I'd like to project it onto the x-axis and onto the y-axis. Well, it seems that the y component is already given, which is 200, and we are interested in finding the angle between the resultant and the y-axis, or the resultant and the y component. We don't know what the x component is, but we do know what the resultant is and its y component. So let's again think of this in terms of SOHCAHTOA. 500 is the hypotenuse. 200 is adjacent to the angle that we're interested in. So therefore we have hypotenuse, we have adjacent, we must use cosine. And by definition, cosine theta is equal to adjacent over hypotenuse. Adjacent is 200, hypotenuse is 500. So therefore, if we're interested in theta, we should find the arc cosine of 200 over 500, and you want to plug this in your calculator. Theta is equal to 66.42 degrees. Alright, how about the final problem? We have the x component of an unknown resultant. The resultant is unknown, but the x component is 300, and its y component is 400, and we are interested in finding this angle. So again, 300 is adjacent to the angle, 400 is equivalent to this vector, which is opposite of theta, so that's opposite. So we've got adjacent, we've got opposite, we must use tangent. And by definition, tangent theta is equal to opposite over adjacent. Opposite is equal to 400, and adjacent is equal to 300. So therefore, if we're interested in theta, all we have to do is find the arctangent of 400 over 300, and you want to plug this in your calculator. Theta comes out to be equal to 53.13 degrees. I hope you're having fun.